So let's continue. Our next speaker is a technical lead, a manager, a coach, and he likes to say that he has a job, a hobby, not a job. So join me in welcoming Artiom from Data with Adswizz. I'm sorry. He will talk to us about how he manages his analytics streams on Druid.
Thanks.
Good luck.
I don't need that. All right. Thanks everyone for joining. Pleasure to be here. So, what are we doing at Adswizz? I think this is the main question. Oh, pardon? Back? Okay. So who we are, right? Adswizz's main mission is basically to enable audio publishers to monetize their content by connecting them with the advertisers by providing an ad, a relevant ad to a listener. So this is the main mission that we have. Now, with this in mind, basically, when it comes to the ad tech world, why this cost efficiency? That's the question, right? Well, in each of the business that we have in big data worlds, that's the most costly ecosystem. So our goal is to have this big dream of spending $0.001 per 1,000 served ads, right? With this in mind, well, which is the most expensive, ecosystem, as I said, is the big data services that we have. So I'm going to start with what was the evolution of our architecture? How did we start it? So I remember today that I joined Adswizz in summer in 2012. And I joined this big data project. It was a typical CAP architecture. Basically, you have this real-time processing, you have the batch processing, and there are a few events that you would process on the real-time, lots that you would do on the batch processing. You would define those data sets basically specific to your business needs, like, I don't know, country, city, and then sales probably, and then whatever you have a new request, you would have to change that and change city with country, compute again the metrics, do the reduce phase. That was really nice. So we've been using like Apache Hadoop, Pig, HBase, some of the things that probably are not known, like Facebook Scribe. So first thing that we thought is like, can it be done better, right? So we changed it from the Hadoop to Spark. That was the big step, let's say, when we reduced the costs. But then we thought, well, each time when we are building something, it takes time because you have to build new data sets for your customers. So we thought, is there another way to think about it? Like you give all the ingredients to your customers and they slice and dice whatever they wish it to be done. And that moment we started a project somewhere in 2016 on the CAP architecture. For those that are not familiar with the CAP architecture, basically the main goal of it is to have a single technology to support both real-time and batch. So with that in mind, we start to figure out what are the new technologies that we can use to reduce the burden of investing in batch and real-time kind of processing, right? And also to have this capability of not creating new data sets, but really give all of the dimensions, the segments that you would like to do the breakdowns and metrics to the customers. So here comes into the place the Apache Druid. We'll try to focus on the moment when basically all the experience that we have, is it a good or bad tool, you will define for yourself at the end of the talk. And basically we'll try to focus on 2016 and 2022. So why Druid, right? Why not another database? Well, we tried different databases at that moment. We tried ClickHouse, we tried MemSQL, obviously Druid. And basically the reason was all of them were working. MemSQL was a paid version, so we figured out that probably that's not a good opportunity for us. You'll figure out why later. And then it was ClickHouse or Druid, and because we like to contribute to the open source community, we said, well, Java-based technology, why not? So in a nutshell, what it gave us was a single technology for both real-time and batch. Query data in real time. So we wanted to move the batch layer to everything streaming and real-time query. Slice and dice dimensions. So basically try to build big data sets, give all of that data to your customers so they figure out for themselves what reports they want to build. And also we try to think about, are there like really powerful compressions algorithm behind the tool so that we do not spend money on the storage itself while persisting the data. So was it the right decision, right? Well, this is what we are running today in production. So by the way, who knows about Apache Druid in here, who is using it? Okay, a couple of people. The common components of an Apache Druid, because I see that there are a few of you that knows it, basically you have these master servers that are figuring out all the data the way it is partitioned and sharded among your clusters. So that's the master servers. Plus you do all the operations of what you want to ingest, what you want to remove through the masters. Then you have the query servers that knows where the data lives, and it knows to go and fetch it from different data nodes. And then you have like what is called external services, where basically it's all of your data persisted for like any kind of crisis. We are using deep storage to persist all of the data also on S3. We have Zookeeper to manage all of the metadata on the clusters, plus the leader election of the servers. And more than that, actually, we have also took all the meta and put it also on the Aurora Amazon. So that basically whatever we are losing all of the data instances in here, all the components, we can rebuild the cluster easily from just the external dependencies. But going to, was it the right decision, right? So today we ingest around 3 terabytes of data per hour, which is around 150,000 of events per second. The storage of the cluster, if you thought, is it mature enough to use Druid? Well, we are storing 750 terabytes. I think it's even more today. The span of the interval that we are storing is 15 months. And that materializes in like around 600 servers that are maintaining all of this. Queries are a few, like 90 requests per second. And then we have around 17 data sources and a couple of materialized views. So when you think about when we started this project, right? You start with, so we started like in incubator phase of the Apache Druid. So we did lots of mistakes. And sometimes thinking like, it would be nice if somebody would tell me at that moment, you have to do it that way. And usually when it comes to this, you have things that you can, learn from somebody and try to apply them. And then you have things like you can observe and then, improve. And we are not talking about premature optimization in here. So what are the tips to make your Druid infra more cost effective? So here comes the first tip. Druid is really flexible. So you can throw JSONs into it and it will just automatically do everything for you. So you can go schemaless. That is really nice for, let's say, the business needs, like you want to be really fast time to market. You don't want to process anything from your JSON. You just throw it into Druid, you can query it. But here comes the drawback, right? Like you're paying the price for something. What is that price? Well, you can ingest some bad data because JSON is a schemaless. So you don't know really what's inside. You're unaware of the data. You might add additional monitoring because then you'll have to analyze what's inside, right? And then when you figure out what is inside, how do you clean that up? And because Druid is a time series database, basically you have to go and reprocess everything from the past until now. And that obviously is costly. So here is the advice. I mean, try to not use schemaless when considering Apache Druid. Obviously, it depends. It's a trade-off. Like if you have like a, let's say, monitoring tool that you would like to throw anything and just analyze what's inside, that's probably your case. In the case of, let's say, more business-oriented, like product thinking, consider schema, because if you don't control, you cannot optimize in the future. Next advice is define your data sources as a product. So we've heard this in the previous talk yesterday in the data mesh. And actually, I was laughing because this is something that we did in like 2016 when we did a big mistake. So we consider a tool and we said, why not throwing everything into the data source, database into a single table and then query that table. Like I would say, I have listener data, publisher data, ad data, some target data. And then we have the ETL somewhere that joins the information, does something, right? And we just throw that into data sources that we would explain as specifically for a customer size, like how much traffic does a customer does. That would be a data source name, like small, extra small, large, big mistake. Why? Well, you do not benefit from the compressions. You have lots of cardinality of the data. You are struggling around with it when you query the data because some of the customers may impact each others. And then obviously, if the data does not belong to the same domain, you have lots of nulls where you actually allocate some of the things that probably you will not consider for your persistent storage, like you increase the size. So when we talk about this, think about data as a product, and I've heard yesterday people, they ask like, well, yeah, that sounds nice, but how do you define that? Actually, there is a simple exercise. The way we did it is that we tried to find the main actors of a platform or an application, call it, and those actors, what are the actions that they do? That was the question, right? Because we have the ETL and data engineers, they're struggling to understand all the domains. Those are the main questions that we did. Like, what are the actors of this ecosystem, of that application, of that product? What are the actions they are doing? The actors obviously are the breakdowns, like the dimensions that you would like to slice and dice and the segments. And the actions are the metrics. And well, an action usually today, it's an event that we are producing, right? And the question was, how do we challenge the events? And here comes the next advice is, well, if an event or a metric that you're creating does not change the behavior of your business, probably you don't need it. So in this particular example, what we did, instead of having these data sources like large, extra large, small, we created them specific for the product needs. So just by doing that, we basically reduced the size by 35%, not everything in single bucket, think as a data product. And also it was easier for us to manage, like, hey, this data belongs to that product, so just consider that. So you had better compression, better persistence, and better observability from the product size. Like, these are the metrics and segments that I can use. Advice number 3. When you think about the Apache Druid, so we talked about like data as a product, but sometimes you have some of the customers, has been mentioned also, that they are using your ecosystem, but they don't really bring lots of money. So sometimes you want to challenge some of the customers by saying, hey, probably you don't need 15 months of data, but you need just probably 1 year or just 3 months of data, right? Because you don't really need that data. So a simple advice in here is, when you try to think about time to live TTL about a specific customer, probably it makes sense to create a materialized view of it, like a separate data set with the customer in it. And then what you can do with this, it's pretty simple, right? So you just shorten the TTL for your data source per your customer's needs. There are some downsides of it as well, like in trade-offs in the architecture. You'll have to probably maintain it through an API, which customers go and where on what data source, which might be a pain, but that's a simple routing at the end, right? So it's a trade-off. Next advice is, so actually this is one of the biggest values, I would say, from the Druid, is that it does the compactions. And when you think compaction, we did a mistake, another one. We started the project, we throw a lot of data, you've seen lots of data, so we start compaction later. By doing that, Druid supports natively to do the compactions of the data that you have, but the problem was that it was struggling with the performance because there was lots of data, so you would impact the query performance just by doing your compactions on the same cluster. So what we did here, basically we externalized the native compaction from the Druid to an EMR cluster by doing MapReduce job, running the jobs from the Druid itself. And basically we've been doing all the compactions on one side and then just plug it in back to the Druid and exposing it to the customers. So big advice, think compaction early if you want to consider Druid in the future. Think about it as using the native one, so don't try to do what we did. But if you have already an up and running cluster, well, probably this is your choice, so that the customers are not impacted by what you're doing on the cluster itself. And this is actually an example. So you can see on the right, we have data that is not compacted. Unfortunately, we cannot see it properly over there, but it's 4 terabytes. This is daily, I suppose. And you can see the compaction, the way it runs after, how the data looks, and basically uncompacted data. So what are some key takeaways if you would have to start Apache Druid today, let's say, right? So consider schema. Do not go with the schema-less. Properly define your data models. That would reduce the size, give you some observability, and you'll be able to control better your data. Flatten, explode, and normalize your data set. It's really nice that you have this capability to throw nested structures into Druid and then query them, but that brings some penalties. You'll pay the price of the persistence storage because you'll ingest nested structures, and you'll pay the price for the querying because you'll have to index everything into the memory, the whole row, and then going through each of the, going through the parsing of the path of the JSON, let's say. Try to ingest immutable data. Of course, this might be based on the business case, but what may happen is that you might see different results. So let's say I'm putting inside the database names, but the name can, let's say, change. So I have a campaign that is running for Christmas, and then I put the same campaign and just changing the name, let's say, not Christmas, that something in, spring. Well, obviously you'll see two rows that makes no sense. And also you'll pay the price of the same column that will not have better roll-ups because there is a new name in it. Isolate data sources if different details are required. So this is the use case when you have customers that probably don't need the full span of the data. Add compaction task early in the phase of the project. And then comes the next phase, right? So you have to monitor the way the data is used. So we try to figure out some of the intros when you start, and now let's go with the I observe and I optimize. First thing that we've seen, we are using Grafana to monitor the Druid cluster itself, and first thing we've seen is that actually in 80% of the cases, customers, they do use only 1 month of data, like give me all the results for the current month. Give me a current month, give me current month. And then we figure out, well, probably it's not worth it to keep a big cluster or big instances for the, the whole span of 15 months. Probably it's better to have tiers. So we created the hot and cold tiers. We put more power on the 30 days. 90%, sorry, I was wrong. So we put more power on the 30 days, and then you put less resources for the 10% of the cases where you have like some of the customers that would like some data from the past year or beginning of the year just to figure out something. I also listed some of the EC2 instances we are using today. If you need more details, just reach me after the presentation. Right, so yeah, advice is try to observe the data, the way the queries are used, and try to create this steering so that you do not spend a lot of money on the whole cluster. Yeah, question?
Yeah, so what's the customer experience for this? So do they need to specify whether they want to look at the current month, or they need to select a specific cluster?
No, so this is done everything behind the scene. So we have this routing, basically, in the previous slides. There is a router that basically tells you wherever you go on one tier or another one. So this is really, agnostic for them. They just use the cluster. And because in 90% their satisfaction, it's high because you get the response fast, then basically 10% they are okay to wait more than 1 second to get the report, right? Like it might be 1 minute, they don't really care. Okay? Cool. So then we thought next. So we are running everything on Amazon. And we said, well, that cold tier, does it make sense to go on the spot instance type? Well, it does. Actually, we succeeded to reduce the cost around 50%, between 40 and 50%. Amazon, they are saying that it can be done even more. The idea, spot instance, I suppose most of you knows what does it mean. It's basically bidding based on an instance that is not used on Amazon, so you can get it until somebody else with on-demand, is paying the price. And we reduce the cost here as well. We are running that on the spot instance type. The advice is to consider that. Do not consider it for the hot tier because that's your biggest impact, right? But you can consider it also on the spot. What you shall think here is probably your API will have a challenge to do this retries until it gets the result, right? Because you can lose a spot instance, you'll have the partial result, and then you'll have to retry because there will be an exception. So that's a small risk, but the question that you might have is it worth it, the cost versus the customer satisfaction in here. And then I'm seeing this time to time that, and we did the same. We're trying to give a big data set for everyone, like use it. But then the question is, well, what are the segments or dimensions that they are doing most breakdowns? And then when it comes to our case where we have more than 10,000 dimensions that you can do slice and dice in your dashboards, we notice actually that there are a few that are used. So we said, why not creating a materialized view for it? And then your queries, basically, when they aggregate, they just consider that data. So the advice is try to think of the products that you are building. Also to create some materialized view for specific UIs and dashboards, because you don't want to pay the price for these partitions that you have to load into memory from Apache and then, doing the aggregates just because you're using a few of them. Probably it makes sense to create a smaller one, materialized view, and then consider just those partitions to be loaded. Right, so on the DevOps side a little bit. So initially when we started, so basically we have this ingestion. Middle managers are the one that is responsible for ingesting your data into Druid. They basically are spanning lots of workers, whatever it's streaming or it's batch, those will be the one that will be responsible to ingest your data. And then eventually it will be back into the historical nodes, which is like long-term persistent layer, let's say. And we did it separately, so we put middle managers aside of the histo nodes, and we had to manage them separately. There are trade-offs. So on one side, you're winning the fact that you do not impact the ingestion with the query layer, basically, that are serving the data from the historical nodes and the middle managers. But on the other side, we noticed that why not increasing the instances from EC2 and putting both services on the same side, because you have real-time and, let's say, long-term persistent, like historical data on the same nodes. So it's actually more efficient from the costs. So you're paying the price once, you have both services on the same side. So yeah, think into this direction. You will see that actually you reduce lots of instances. So you can bring the instances that you reduced in here as a more resources for the EC2s that you have. So what are some key takeaways related to this observe and react? So yeah, monitor data usage and query performance to understand how the customers are using your data. Based on that, then you can consider also probably some materialized views. Instead of paying the price with more resources, you just need few smaller data sets to be exposed. Consider tiering, because you don't have to keep a big monster just for 15 months. So you just need probably 30 days, 60 days, put lots of resources in those and then, reduce on the other side. And then, yeah, this is something that we also did. So you notice we have this hot, cold, and then we introduced the spot. One thing that we did more is like we said, okay, probably it makes sense because it's spot to try different Amazon zones for this. When we bootstrap instances or whatever, there is a problem on a single zone, we still have the other zone to bring the data more. So this is related to high availability, basically. And then, yeah, consider spot instances for better cost efficiency. And this co-location of middle manager and histo nodes if you want to reduce basically more instances of your cluster. So we are back here. So this is basically a really high-level overview of what were the advices from 2016 and until 2022. And usually when you think about it, you've seen that there are lots of components. You're struggling with the data schemas, then you're struggling probably with you have to understand the Apache Druid from the coding as well, not just documentation, because sometimes, we're inflating things. It took for Apache Kafka like lots of releases just to say they are fully transactional. So here is the same. I mean, sometimes you might consider that probably the investment of the people that are working with this, it's not worth it, or you might bring even more cost reduction just by paying somebody to do it, as a paid version. So here comes the imply, something that we are starting this year. Basically, you can see this big monster. You have to do plenty of monitoring on each of the nodes to understand, the application layer, the instance layer with all the metrics. Then you have the interconnection between them. So plenty of issues that may happen. Probably it's just worth it instead of paying a team of DevOps to manage that. Probably it's worth it for you, but that depends on the business case. Obviously, to try imply, so you have on-prem on their side, you have the cluster management and monitoring, and obviously this expert support that, they give you advices from different other companies the way the tool is used. So that's all cool. And Apache Druid, it works for us, right? But is there like anything else that can be done with this tool in the future? And here are some of the things that I'm, keen to see in the future, like anxiously waiting. It would be nice for the Apache Druid to read the data directly from S3. So you will not have to plug in the disks, to load all the partitions in it and then expose it to through the aggregator. So probably it just makes sense to read it directly from S3. These are the ideas, so this is not something that is happening today. Then probably it makes sense to plug in the data from the other clusters. Like, for example, Snowflake does this pretty nice. Like, you have somebody that did the data set, like some partitions, and then you just take the aggregators, let's say, and plug in the data on the other side, and you don't have to recompute it or, copy it to your cluster just because you want to need it, to use it. Then this supervisor to support multiple topics ingestion. So Druid supports today an ingestion basically for a single data source from a single Kafka topic. So if it's streaming, let's say, and you have this connection, so you'll have to consider combining lots of events into a single Kafka topic. So because just, Druid supports it that way, which is not really nice because usually this transportation layer is meant a little bit different, but would be nice, to see this in the future. You will not have to, do lots of group buys and joining the information, especially in real time, it's a real pain. This full async query support. So actually, there is a new version that came these days. Didn't check it yet. But the idea is that in the past, we've built this asynchronous with the Druid like in-house. And it's not fully async because you are still interconnecting with the, through HTTP request, you're waiting for something, then you have to trigger it again. So you are building an ecosystem around Druid just to support asynchronicity. Would be nice to see that because it would reduce even more the cost plus maintenance. And one thing that is super important, especially on the security side, GDPR, is these ephemeral columns. Like, would be nice to see marking columns that I don't really want or rows inside the partitions that I don't want, right? And then eventually for them to be removed. Today, if you want to do that, you have to re-ingest everything for a specific interval because it's time series, right? And basically, this is something that I think will bring lots of value also. You'll not have to have jobs, reprocessing everything, paying the price just because you want to eliminate something. So with that said, thank you.
I think we do have some time for questions if there aren't any.
Yeah, we have one of that.
Hello? Okay. So, hello, thank you for your presentation. First question is, does it support updates or writes?
Yeah, so everything, it supports appends. It does not support updates. Basically, everything that you ingest into Druid is immutable. It remains as it is.
Okay, and second question is, you mentioned accessing the data through an API to, let's say, make things transparent regarding to the your table structures and so on. What type of tools do you use to access Druid? I mean, do you have like normal BI tools, I don't know, Tableau, stuff like that, or do you have custom stuff? What's that?
So related to the APIs, basically we built one with the Spring Boot just by integrating through HTTP and the JSON protocol, basically schema that they have to operate. And we exposed that API, and actually we exposed Druid internally to be used with the Redash, Superset, and Grafana. On the Grafana, you might find that the plugin is not really up to date, so that might be an issue. You'll need to go with a really, you know, somewhere in 2018, probably Grafana version to try to use the plugin. On the other side, it's really supported because you have this HTTP support, so it's nice. Now with the new SQL kind of movement, actually you can plug in directly and using, you know, the query layer through the SQL language, which is also nice.
So have you tried the traditional type of BI tools like Tableau, Looker, I don't know, Power BI, stuff like that?
We did an integration with Tableau. Although one thing that was, I think, struggling is the way you manage to build your queries. Because usually the way they thought it's working is like I'm giving you the 15 months of span and trying to get the data. But you need some kind of aggregators, right? Like give me at least daily data or give me like weekly data, doesn't matter. So it's really a matter of how you think of, so you can do the Tableau integration. But the problems will come when you are building your queries. How do you fetch the data properly? I think that's the main issue. We had a customer that I think did for a single hour around 200 megabytes compressed data. And they've been trying to do that daily, which is kind of insane. So yeah, you really have to challenge a little bit the integration.
Okay. So essentially, basically, you would need to, I don't know, maybe move it, do the materialized views approach and move it to a separate database where it's...
Materialized views might be an option, yes. So as I said, there is no one dataset fits it all. So yeah, that's one option, or just challenge the query, right? So like give it a, you know, less interval or fewer metrics. Yeah.
Yeah, okay. Usually when you use these BI tools, they generate the SQL themselves and there's no way you can adjust it.
That's why we put in place the API, basically to try somehow to reduce, like if somebody will ask more than 5 dimensions as group bys and with, I don't know, 15 metrics, that's probably something crazy you want to see. So probably it makes sense to think different and then to do not expose your Druid as like a data lake where you go and, you know, fetch data like from Athena and you wait for 15 minutes something to be aggregated. Probably it makes sense this one to be like really product oriented and then think about, although it does, you can wait 15, 30 minutes and it will do the result, but probably you don't want to expose that, you know, through an HTTP just by waiting gigabytes of data to be downloaded. So probably it makes sense just to take some kind of, you know, S3 data or something that is already pre-aggregated for you and just use that.
Okay, understood. Thanks.
Thanks.
Hi, hello.
Hey.
So if I want to ingest data from an SQL database and a NoSQL database into a single query, how can I do that?
So I suppose you'll have to create your collectors by querying basically your database and then ingesting it into Druid. Although I think there are some of the collectors already exposed into the open source community that you can use, like some facilitator to just, you know, query your MySQL data and ingest it in here. But usually you use like a job in between. So there is no such thing as like embodied it into the ecosystem directly to do that. Although you can check the interface, so there are like ingesting it from a streaming kind of fashion, Kinesis, Kafka. You have it, you know, to be ingested from file systems, S3 and the other. But there are some of the ingestion, let's say, processes that you'll have to use a collector that will fetch the data and then push it to Druid.
Okay, so it's not a real-time like thing.
It depends. If you want to go with the MySQL, like in your case, probably you'll need a change data capture somewhere, throw it into a stream, and then ingest it in streaming fashion. If you don't really need this real-time kind of fashion, then probably just create batches that does the outcome of the database itself, and then you throw it into Druid.
Okay, thanks.
Really great presentation, thank you. I have two questions, basically on fail-safes and on scalability. My experience with having databases running on physical services is that sometimes you have clients creating too much pressure or running a bad query. Is there some kind of fail-safe mechanism in Druid, or what is your experience with that?
Yeah, so Druid, basically the question is if a customer can impact the other customer, I suppose.
Right.
Yeah, it can. But there are two things that you can consider. So one is prioritization of the queries that you have. The second is you can route your queries based on the specific tiers. So you can allocate actually the way we are doing, let's say for the async requests, which might be heavy. We are actually routing those queries to a specific tier that is not impacting the, let's say, UI or customer experience. So this is the second one. And then the third, you can use like some kind of prioritization queuing mechanism that is in place in Druid, where you can specify what are the queues that I would like to put my query so that it waits a little bit longer to be taken by the ecosystem when the proper resources are available. Don't remember exactly the property, the way it's named. But for sure, that was actually released, I think, 2 versions ago or 1. Yeah, so
this really answers my question. It's a really good answer. And I'm also curious in your use case, if you scale down or up the cluster, or if it's like a constant size.
For us, it's continuous growing traffic, unfortunately, so you cannot really play with the scale up and scale down. Also, you have to consider that probably it's not the best use case to just scale up and down in here, because it takes time for the historical nodes to, but first you wait for the provisioning, then you wait for the service to bootstrap, then you're waiting for you to announce the coordinator like, hey, I'm also available. And then the coordinator is saying, okay, probably I'm going to throw you these partitions to be loaded. So all of this process, it takes time. So sometimes just, probably you'll not feel it that it's a really good experience, to just scale up and down, although it does it properly and perfectly. It depends really on how do you size the histonodes of how much partitions and gigabytes of data has to be loaded. If it's optimized, like for example, like let's say 700 megabytes of data per each of the histonnode with like 500 RAM usage, probably that's a perfect fit, so you can play with the scale up and down. If you go like as we are doing, let's say on the hot tier, where you have like 2 terabytes of data on 256 RAM or even less sometimes, it takes time for the data to be re-indexed, right? So probably that's not the best case just to scale up and down.
Makes sense. Thanks a lot.
Okay, if there are no other questions, thank you for your presentations.
Thank you.
Thank you for your questions. Let's get a coffee so that we can keep the energy up, and we will rejoin at 20 to 12.